Chapter 15 of Class 8 Science, Some Natural Phenomena. We are already familiar with some natural phenomena like cyclones, winds, storms, tornadoes, volcanic eruptions, etc. But in this chapter, we'll mainly deal with two destructive natural phenomena, which is lightning and earthquakes. So let's begin the chapter. So first in this chapter, we'll see what is lightning. To learn about lightning, we should first know about electric charges, that is charging by rubbing, then the types of charges and their interactions, and transfer of charges. Then we'll see how the electric charges are related to lightning. Then we'll also study about the necessary steps that should be taken during lightning. And finally, we learn about earthquakes, how earthquakes are caused, and also the protection against earthquakes. So first let's see an interaction. You might have seen sparks on an electric pole when the wires become loose, or you might have also seen sparks when a plug is loose in its socket. So lightning is also an electric spark, but on a huge scale. We know that sparks are due to electric charges. Hence we can say that lightning is caused by the accumulation of electric charges inside the cloud. So let's see how sparks came into notice. During 600 BC, the Greek noticed that when amber is a type of a tree resin, when it was rubbed with fur, it attracts light objects. Okay. Similarly, if we try taking out woolen clothes, your hair stands out at the end. Or if you take out the clothes in the dark, you will see a spark or hear a crackling sound. So in 1752, Benjamin Franklin, he was an American scientist, he showed that the lightning and the spark from your clothes are essentially the same phenomenon. So what happens here is that when objects are rubbed against each other, they acquire a small charge. That is, they create sparks because of that. That is static electricity. So in order to understand lightning, first we should know what are electric charges. So in this chapter, we'll see the properties of electric charges and how they are related to lightning. So we saw that when objects are rubbed against each other, they acquire a small charge. So let's see more about charging by rubbing. So in order to understand this, let's consider an activity. Take a small ball pen refill and rub it vigorously with a piece of polythene. Bring it close to some pieces of paper. What can be observed? So when the plastic refill is rubbed with polythene, it acquires a small electric charge, and as a result, it attracts a small bits of paper. Similarly, when the plastic comb is rubbed with the dry hair, it also acquires a small charge and it also attracts small bits of paper. Hence, we can say that these objects are charged objects. Types of charges. So in order to understand the type of charges, let's consider 2-3 activities. In the first activity, inflate 2 balloons, hang them in such a way that they do not touch each other. Now rub both the balloons with a woolen cloth and release them. What can be observed? We can observe that the balloons, they repel each other. A charged balloon, it repels another charged balloon. Now repeat the same activity using pen refills. Rub one pen refill with polythene and place it carefully inside the glass tumbler, and rub the other refill also with polythene and bring it close to the charged refill. We can observe that the charged refill, it repels the charged refill. So in both these cases, we can see that the charged objects that are made of the same material, they are repelling each other because they have the same charge. Now let's consider 2 charged objects made of different materials and are brought close to each other. So in this case, we rub a refill and place it gently on the glass tumbler, and as before, and we bring an inflated charged balloon near the refill and observe. What can we see? We can see that the charged balloon, it attracts the charged refill. So from all these observations, we can see there is an attraction repulsion of charges. So we can say that there are 2 types of charges. So let's see what are the types of charges. So the 2 types of charges are positive charge and negative charge. Hence from these observations, we can say that like charges, they repel each other. That is, if we bring 2 objects, both positive or both negative, they repel each other. And unlike charges, they attract each other. That is, if one is positively charged, another is negatively charged, they attract each other. Now, the electrical charges generated by rubbing are static charges and they do not move by themselves. So, we are studying charging by rubbing. So, those static charges, they do not move by themselves and they are generated by rubbing. Now, when charges move, they constitute an electric current. For example, the current in a circuit which makes a bulb glow, or the current that makes a wire hot. It is nothing but the motion of electric charges. So we saw the types of charges, positive charge and negative charge, and their interaction. How do they interact? Like charges, they repel each other, and unlike charges, they attract each other. Now let's study about the transfer of charge. So in order to understand this, let's consider an activity. Take an empty jam bottle and take a piece of cardboard slightly bigger in size than the mouth of the bottle. Now pierce a hole in it such that a metal clip can be inserted. Now open the paper clip as shown in the figure and cut 2 strips of aluminium foils and hang them on the paper clip. Now charge a refill and touch it with the end of the paper clip. What can be observed? We can see that the aluminium foil strips, they started to move and they repel each other. So what happens here is that the aluminium foil strips, they receive the same charge from the charged refill through the paper clip. Why? Because the paper clip is a metal and metals are a good conductor of electricity. Hence the aluminium foils, they receive the same charge as that of the refill. Now as the strips, they carry similar charges, what happens? They repel each other and they become wide open. So such a device that can be used to test whether an object is carrying charge or not is known as electroscope. Electroscope is a device that can be used to test whether an object is carrying charge or not. So from this experiment we can say that the electric charge can be transformed from a charged object to another through a metal conductor. Now repeat charging of the foil strips and now touch the paper clip with your hand. What can we see? We can find that the foil strips collapse as soon as you touch the paper clip with the hand. Why does it happen? It happens because the foil strips, it lose charge to the earth through your body. We can say that the foil strips are discharged. So this process of transferring of charge from a charged object to the earth is called as earthing. What happened here is that the charge inside the foil strips, it was transferred to the earth through our body. So this process of transferring of charge from a charged object to the earth is called as earthing. Now earthing is provided in buildings to protect us from electric shorts due to any leakage of electric current. So we studied about electric charges, charging by rubbing, the types of charges and their interaction. Now let's see how these electric charges are related to lightning. So the next topic of this chapter is story of lightning. Now when there is a thunderstorm, the air currents, it moves upwards while the water, it moves downwards. Now these vigorous movements, it causes a separation of charges. That is, the positive charge, it collects near the upper edges of the cloud, that it is moved to the top of the cloud. And the negative charges, they accumulate near the lower edges of the cloud. Similarly, we can observe that there is an accumulation of positive charges near the ground as well. So we saw that the cloud contains both positive and negative charges. Now when the magnitude of this accumulated charges become very large, the air, which is normally a poor conductor of electricity, it starts conducting. So what happens? The negative and the positive charge, it meets, producing streaks of bright light and sound. We saw that there is a positive charge on the top of the cloud, the negative charge, and in the ground also there is an accumulation of positive charge. So the negative and the positive charges meet, it produces streaks of bright light and sound. Now these streaks can be seen as lightning and the process is called as electric discharge. Now the process of electric discharge or lightning can occur between 2 or more clouds or between clouds and the earth, as there is positive and negative charge inside the cloud itself as well as the earth. So the process of electric discharge can be between clouds or between clouds and that of earth. Now we understand the basic phenomenon of lightning. However, lightning strike could destroy life as well as property. It is therefore necessary to take measures to protect ourselves during lightning. So the next topic of this chapter is lightning safety. Now during lightning and thunderstorm, no open place is safe. A house or a building is a safe place. So hearing a thunder, it is an alert to rush to a safer place. Now if you're traveling by a car or a bus, you're safe inside with the windows and doors of the vehicle shut. Now let's see some of the do's and don'ts during thunderstorm. Now if you're outside, let's consider the do's and don'ts during thunderstorm. Now open vehicles like motorbikes, tractors, construction, machinery, open cars are not safe. Open fields, tall trees, shelters in parks, elevated places, they also do not protect us from lightning. Carrying umbrella is not safe because umbrella have metal wires, thus it could be harmful during thunderstorm. If we are in a forest, take shelter under shorter trees. And if no shelter is available, you are in an open field, stay far away from all the trees. Stay away from the poles and other metal objects. Do not lie on the ground. Instead, squat low down. What is squatting? It means that you place your hands on your knees with your head between the hands. So this position will make you the smallest target to strike. Now if you are inside, lightning can strike telephone cords, electrical wires and metal pipes. So during a thunderstorm, contact with these should be avoided. It is safer to use mobile phones and cordless phone. Now bathing should be avoided during thunderstorms to avoid contact with running water. Electrical appliances like computers, TVs, they all should be unplugged. And electrical lights can remain on, they do not cause any harm. So these are some of the do's and don'ts during thunderstorm. Now let's see what are lightning conductors. Lightning conductor is a device which is used to protect building from the effect of lightning. It consists of a metallic rod which is taller than the building and it is installed in the walls of the building during its construction. One end of the rod is kept in the air and the other end is buried inside the ground. So this rod, it provides the easy route from the transfer of electric charge to the ground. Now the metal columns which is used during construction, the electrical wires and the water pipes in the buildings also protect us to some extent, but do not touch any of these during thunderstorm. Hence we can say that the lightning rod, even if the lightning strikes, it will hit on the top of the lightning rod and the conductor, it discharges the lightning as it transfers the electric charges to the ground, thereby causing no harm. Now let's study about the next natural phenomenon, which is earthquake. Now what is an earthquake? An earthquake is a sudden shaking or trembling of the earth which lasts for a very short time. It is caused by a disturbance inside the earth's crust and it's impossible to predict the occurrence of earthquake. The weather department, it can warn about the thunderstorm developing in some area, but we are not yet able to predict earthquake accurately. One example of earthquake is one which occurred in India on 8th October 2005 in Uri and Tangdar towns of North Kashmir. And it can cause a damage of human life as well as property in a huge scale. So now let's see some of the effects or damages caused by earthquakes. So what are the damages or effects of earthquake? Earthquakes can cause immense damages to buildings, bridges, dams as well as people. It can also cause fires and can cause great loss to life as well as property. Earthquakes can cause floods, landslides and even tsunami. One such example is the major tsunami which occurred in the Indian Ocean on 26 December 2004. Now what causes an earthquake? The disturbance inside the earth causes earthquake. Now earth consists of three layers. The outermost layer, which is the crust, the mantle and the core. The core is again classified into inner core and outer core. Now the tremors or the movement or the shaking are caused by the disturbance inside the uppermost layer of the earth called as crust. The tremors are caused by the disturbance deep inside the crust. Now the outermost layer of the earth, that is a crust, is fragmented, and each fragment is called as a plate. Now these plates are in continual motion. That is, they are not stationary, they keep on moving. And when they brush past one another or a plate goes under another due to collision, they cause disturbance in the earth crust. That is, when one plate comes near another plate, they either collide with each other or they brush past each other. And because of this collision or brushing, it causes disturbance in the earth's crust. And it is this disturbance that shows up as an earthquake. These are the earth plates that can be observed in the whole world. So the tremors in the earth can also be caused when a volcano erupts or a meteor hits on the earth or an underground nuclear explosion is carried out. However, most earthquakes are caused by the movement of earth plates. Now, although we know what causes an earthquake, it is not yet possible to predict when and where the next earthquake might occur. Since earthquakes are caused by the movement of plates, the boundaries of the earth plates are the weak zones where earthquakes are most likely to occur. So these weak zones are also known as seismic zones or fault zones. So in India, Kashmir, Western and Central Himalayas, the whole of Northeast, Rann of Kutch, Rajasthan and the Indo-Gangetic Plain are prone to danger zone, and some areas of South India also fall inside the danger zone. So these areas where there is most likely to undergo earthquakes are called as seismic or fault zones. Now we studied that the earthquakes occur all the time, all over the earth. They are not even noticed. Major earthquakes are much less frequent. So how can we determine the strength of an earthquake, or how can we measure earthquake? The power of an earthquake is expressed in terms of magnitude on a scale called as the Richter scale. Destructive earthquakes have magnitudes higher than 7 on the Richter scale. For example, both the Bhuj and the Kashmir earthquakes, they had magnitudes greater than 7.5. Now this is the Richter scale. Now let's see how earthquakes are measured. The tremors, they produce waves on the surface of the earth called as seismic waves. Now the waves are recorded by an instrument called as seismograph. Now what is this instrument? This instrument is simply a vibrating rod which starts vibrating when the tremors occur. A pen is attached to the vibrating system, and the pen, it records the seismic waves on the paper which moves under it. So this is a seismograph and this is a seismometer. So by studying these waves, the scientists can construct a complete map of the earthquake and can estimate its power to cause destruction. So we know that the earthquakes cannot be predicted, and we also seen how destructive it could be. So what can we do? We can take necessary precautions to protect ourselves all the time, especially the people living in seismic zones. That is, those areas where earthquakes are most likely to occur. They have to be specially prepared. So in highly seismic areas, what should we do is that the use of mud or timber is better than using heavy construction material. Keep the roof as light as possible. So in case the structure falls, the damages will not be heavy. It is better if the cupboards and shelves are fixed to the walls so that they do not fall easily. Be careful where you hang your wall clocks, photo frames, water heaters, so that in the event of earthquake, they do not fall on people. Now all buildings, they should have a firefighting equipment, because some buildings may catch fire due to earthquake. So it is necessary that all buildings, especially the tall buildings, they have a firefighting equipment in working order. Now in the event that an earthquake does strike, take the following steps to protect yourself. If you are at home, take shelter under a table and stay there. Stay away from tall and heavy objects that may fall on you. And if you are in bed, do not get up. Just protect your head with your pillow. Now if you're outdoors, find a clear spot